Hello everyone, this is the video lecture for College Algebra Math 1314 Section 3.5 Rational Functions. So, here we go. So to start with, it says find the domain of something like this. So before we keep going, what is a rational function? Well, rational functions have a top and a bottom. You can say they're fraction functions. So this is the prototype that we're going to be using a lot, and well, you could see that it's right here. It's very simple to find a domain. Do we have division? Yes. So I set the bottom equal to 0, and then I solve for x, and you can see that this was very simple to find. These are actually called vertical asymptotes. Vertical asymptotes. And what they look like is some kind of line like this, and your graph will go around it but never quite touch it. Something like that. It's like an electric fence. So we found these two answers, and I would love to just say 7 and negative 9, but they're not going to want that. The homework program is going to want a negative infinity to negative 9, union, negative 9 to the 7, union, 7 to the infinity. Each one of these is still a hole in the domain, but now because we're in this section, we're calling them vertical asymptotes as well. So there's your answer. We've seen this before, but just want to show you yet again. Keep moving. Number 2, this is called arrow notation, and it has a lot of advanced topics here, but we've got to cover it, of course. And so there's some language that we have to learn here, and I'm going to say it out loud, and then I'll point at some stuff. X approaches, so that's approaches with the arrow. Negative 2, and that little negative sign in the powers means from the left. From the left. And you can guess that the plus sign is going to say from the right. Exactly. So we'll see that in a second, but let's start with this one. Negative 2 is right here, and they're saying that we're dividing this whole thing down from negative 2 is the cutoff point, and we have the left side, and we have the right side. And the right side goes on for as long as you want it. We're just talking about left and right of this particular border, okay? Well, we're on the left side. We're over here. This is our home, and we're wanting to get really close to the border. We want to keep getting close to that electric fence. And so we travel the path that we see here. Let me try to get a different color here. We're traveling the path here. We're going to try to get really close and keep going, keep going, keep going. And keep going, keep going, keep going, keep going. And I'm looking to see if I can cross. You can't ever cross, but let's just see if you can't. And so where are we going math-wise? Y values. Where's this? It's positive infinity. You would just put a plain old infinity in the box, but infinity is what's really going on here. Okay, so you're on the left side. There you go. Okay, so now it says from the right side, what are you doing? So we're on the right side now, and that means like basically all of this, but you really want to get close to that fence, and so you get close to it, you keep going, closer and closer and closer, closer and closer. Where are we going? Where are we going? Negative infinity. Definitely put the negative infinity in there. I kind of like to think of it like Google Maps, I guess you could say. And you zoom down on your house, and you see a lot of different like neighborhoods and all the different fences that people have. And these people have a dog, and the dog likes to run, and so he runs along the fence line, and he keeps on running. And so that's kind of what I see all this stuff as. But up to you how you want to picture it. So 3 is this fence line. Let me start using a different color. So 3 is going to be this fence line right here. So we're looking at this fence. And again, this fence is a left and a right side as well. And we're wanting to start on the left side. So we're on the left side of this fence. We're over here. I'm going to follow that line. Where are we going? Positive infinity. And I want to be on the right side of the fence. So I'm on this fence. I'm on the right side over here. Follow the line. Keep going. And we're going down to negative infinity. Okay. And finally, we've got these approaches, negative infinity, positive infinity. This is a little different. So negative infinity is way over here. And so if I were to keep following this path right here, and we're never changing its y value, what's the y value eventually going to be? Is 0, basically. And the same thing for over here. If we're going to positive infinity all the way that way, like we're going, like I'll show you, we're going this way. What's the y value for that? What's the height eventually is, again, 0. You might have a 0 here. You might have an actual number. It just kind of depends on what the graph looks like. So there we go. We did the whole thing, and now we get to move on. Number 3. Seems pretty easy. It says find the holes in the vertical asymptotes. Well, in number 1, I said they're the same. So now all of a sudden they're cutting them apart? Yeah, kind of. The holes are removable discontinuities. That's a big word for hole. And I'm going to just say it's the stuff that you can cancel, okay? The vertical asymptotes do not cancel. So if you see something that cancels, like, I don't know, these x's, that's going to be a hole. So that's going to go in here. But something that did not cancel, like the 6, is going to go down here in the vertical asymptotes. Well, what I want to do is find out what those actual values are. And so I'm looking right here, solve for x. Well, there's no number, so it's going to be a 0. And I already said that those are going to cancel, so therefore it's going to go into this box here as a 0, right? Maybe. So x equals 0 is the appropriate answer. But sometimes it has a blank box like you see, and you have to type x equals 0. Some other times they'll have x equals in the box, and you just type a 0 and not the x equals because you already have one. Whew. It's a very commonly missed question, all because of format. This one's super easy here, x equals 6. That was not going to cancel. So then you just put it right here, and there's your answer. I think the math side's very simple. It's just what cancels, it's a hole. What doesn't cancel, vertical asymptote. Keep going. Number 4. So now they're asking for horizontal asymptotes. And there's all 3 of these I put for number 4. They're actually separated, but I think that it's going to be easy to put them all together. To find these horizontal asymptotes, we need to follow the 3 rules. The 3 rules. And that's why we have 3 different questions here. And so when I'm looking at the 3 rules, I'm always wondering about the top and the bottom degrees. So remember when I say top and bottom, I'm meaning top and bottom of my function. And so I'm going to say, and this is my degrees. I'm always looking at the degrees here, okay? So if I have my degree of the top is less than the degree of the bottom, then that's going to be rule number 1. So I'm going to just do rule number 1 right here. A perfect example is right here. Look at that. We got a 1, and then we have a 2. And so my top is less than the bottom. We're just looking at the degrees. So the answer for this is going to be y equals 0 is your horizontal asymptote. So you literally just type y equals 0. That's it. You got it. You're done. Okay, rule number 2. Go figure that there's the second one right here. What if you have the degree of the top is equal to the degree of the bottom? And so again, you can see that we have the degrees are the same. Nothing else matters to me. I don't care about the 4, 3, or the 12, or nothing. I care about that's a 2, and that's a 2, and they're the same. And so if they're the same, I say y equals the front fraction. Now that's my own English for what's going to be going on here. But I want to see what you can see is the front fraction. What do you think? It's 12 over 4. Wow. And so if you take 12 over 4 and divide it, your answer is going to be a 3, isn't it? 12 divided by 4 is a 3. Remember to type y equals 3. It's very important to do all that. And, of course, rule number 3, the last one. What if you have your top is greater than the bottom? And you can see that here, 3 and 2, so that's bigger. What do? No horizontal asymptote. That's your answer. You click none. Click the none box below it, basically. So yeah, there's none. You just do nothing there. So those are the 3 rules. There you go. And we did 3 problems demonstrating what the horizontal asymptotes would be. It's actually pretty simple. I wouldn't overcomplicate it. All right, number 5. This I would overcomplicate because it's a lot. But I want to give you steps. I want to give you like a mini formula for each one of these things that we have to do. Okay, so first off, symmetry. They're asking if this problem is even, odd, or neither. Now, they're going to use language like y-axis symmetry and origin symmetry and all that stuff. But ultimately, we're just doing an even, odd, or neither problem. And so what did we do back then is look at the powers. And so I look at the powers as a 1, as a 0, and already I got an odd, I got an even, no good, neither. I'm not saying every single problem's neither, but it's definitely more prevalent than the other 2. Okay. Y-axis, what do you do here? What you want to do is plug in x equals 0. So you're plugging in 0, and you want to see what you're going to get. This is going to confuse me, so just like get rid of that thing, because that's not really part of the problem. So here we go, 0 plus the 2, 0 squared plus 0 minus the 12. And so I got negative 1/6. And that's my answer. I just plugged in a 0. X-intercepts is when the top is equal to 0. Again, just the whole top here. The top by itself equal to 0. Solve for x. And yeah, you guessed it. X is equal to negative 2. That's going to be... Oh, hold on. The brain wants this. Just the number there. So that's a 0. That's a 0. I'm not going to write it. It's fine enough. Okay, vertical asymptote is when the bottom is equal to 0. Bottom is equal to 0. And so and most of the time here, they don't cancel. I don't think that this one cancels if I had to factor it. Let's go and find out. So I need to factor the bottom. And I'm thinking, what two numbers multiply to a 12 but add up to a 1 would be a 4 and a 3. So a positive 4 and negative 3. And so my answers here would be x equals a negative 4 and x equals a positive 3. You can see that I just switched my signs. And what they want is actually you to write it just like this. The program wants you to be x equals negative 4, comma, x equals 3, because those are two separate equations. And so there you go. And nothing was canceled, so they're not just like removable discontinuities or something like that. Horizontal asymptote, this is the 3 rules. And so if you look back up here, I'm going to just remind you here, we got a 1 power, and here we got a 2 power. So the top here is less than the bottom, and this is an automatic answer. It's y equals 0. That's just rule number 1, y equals 0. You're done. Very simple to get that. For the table, it's kind of hard to describe without showing you, but they have a y, x and a y, and they're going to choose numbers for you, negative 2, negative 1, 0, 1, and 2, and you go and plug these in to go and find out what those values are going to be. You're going to get fractions. It's not very fun. I would definitely recommend an advanced scientific calculator of some kind. Graphing calculators work fine too, I suppose. But eventually you're going to have to use a calculator to figure out these fractions and stuff, okay? I am not going to do that in front of you here. I mean, it's just a lot of time, but all you need to do is plug that in, and you get a number, and you keep moving, okay? Ultimately, they say find the graph, and you know how to find a graph of something like this, right? You use a calculator. Wow. So I'm just going to rewrite this here so it's clean, so I can look at it. And so if you just use that in the calculator, the graphing calculator, you're done, basically. Very simple. But I want to use a lot of the answers that I have here to kind of show me how that all worked out. So there was no symmetry, so that didn't help me. Y-intercept a negative 1/6, so that would be, I don't know, somewhere around right there maybe. Okay. I have a 0 at negative 2. It's crossing through right there. I have 2 vertical asymptotes at negative 4. And at 3. Okay. I have a horizontal asymptote at 0, and so that's going to be like right here on the axis. And most of the time with these asymptotes, you can't ever cross them, but here we are. It just happens with the horizontals occasionally. But again, all this is just easy to graph on the calculator. And then you can use your table to kind of help out a little bit if you want. But ultimately, it's going to look something kind of like this. It crosses through here, goes through that point, and then it does something like this probably. As far as what's going on over here, I really wish I could use a calculator, but I'm just going to guess a little bit. So if I had plugged in a really big number up here and a big number here, I'm going to get a positive answer in the end. So I'm guessing it's going to be something like this. And if I plugged in a really big number, like a negative number here, 2 negatives will make a positive. So I would have a negative and a positive makes a negative in the end. And so it's going to be down here. And that's just a rough graph of what it would look like. It's multiple choice. Pick the one that looks good. There you go. You're done. Cool. But really, you're not done. There is a little bit more. This one's easy, but this is the last one, finally. So it's a word problem. Talks about fixed cost and cost per unit or something like that. And they want a cost function. This is just like the general overall cost function. And so you're going to put the fixed cost plus 100x. That's your per units, and then x. That's what they want. To find the average, this is called the average cost, And basically, what you're doing is taking your cost and dividing it into each unit. Well, what you're doing is you're doing what I just said. You're dividing it into each unit x. Then they ask for finding 2,000. When x is equal to 2,000, plug it into the average cost function. And that is, I'll write what I'm doing, but that is definitely a calculator moment for sure. So I'm putting 2,000. Wherever you see an x, put a 2,000. So here we go, 100,000. Make sure you got all the zeros. And I got 150. I'm glad that it worked out so easily. And so this is the cost total, the average cost per unit. So it costs per unit this, but then you have a fixed monthly cost, monthly or whatever it is. So you have a fixed cost, and you have this thing, and so you're distributing that fixed cost among all of the units. So it's not just 100; it's gonna be like 150 to be able to get those to work there. And it says, what does it approach? Well, basically, what if you had x equals like a million billion? What's your y value going to be when you plug that in? Well, it's a horizontal asymptote is what they're asking for here. And so if you were to look right here, that's going to be a 1, and that's a 100, and those are both the same. So top equals bottom, rule number 2. There you go. So we got basically a 100. Just put the 100. Actually, do you put a y equals? I can't remember. I'm going to put y equals 100 just in case, but they might just want the 100. I can't remember what the homework program is looking for, but the answer is 100 basically. So cool. We did it. It's all great. We're done. So thank you very much and have a great day.